Okay, so inheritance is one of those big, three big words in object-oriented programming, right? So we have the encapsulation, polymorphism, and inheritance, and many others as well, but this is one of them. And inheritance is also responsible mainly for the method overriding, and we'll go over that as well, what that means. And we did the overloading last time, right? So I didn't want to talk about it before because we didn't have a chance to cover inheritance yet, because override deals with inheritance with two classes, whereas overload you just basically do it in the single class. Okay, so we'll look at that later on. So inheritance is also known as a relationship versus, if you remember back in chapter 4, we talked about the composition. Okay, that is has a relationship, right? So if you remember the sandwich application, we did something like that, right? The sandwich has a bread class, has a filling class, right? So that is a composition. They have no relationship in that instance because they don't have this inheritance. So when a class inherits another class, then you establish this as a relationship. So just like you are a child of your parents, right, like that. Whereas in a composition will be different. I have a dog, right? So that's the difference between the two here. So we'll look at this a little bit. Here are some rules about there is a relationship or the inheritance. When we talk about inheritance, we always talk about two classes. Okay, one class is always the child class, and the other class is always the parent. And here are just some rules that you can do with a child class and a parent class. So it's a one-way proposition. That means a child inherits the parent, and it's not the other way around. And you don't, well, inheritance in the real world is synonymous to the programming world, but it's not everything true in the real world as well as in the programming. Because in the real world, we inherit certain things from our parents or our grandparents based on their will or how they choose to give you, right? Or maybe inherit nothing. It depends. But in the programming world, it's either a all or nothing scenario. Okay, you cannot inherit only a certain piece of code from the parent class and ignore the others. You can't. If you inherit if you're a child class of a parent class, that means you own everything in the parent class, whether you like it or not. Okay, plus your own, right? So that's why it says superclasses. Again, that's the parent classes are always smaller than subclasses, right? Because the parent class has 10 functions, and if you're a child class, you inherit the parent class. You own those 10 functions plus your own, so you always have more. Okay, so the subclasses are always larger, and there are more specific, because usually you have very specific functions and methods, and we'll do some examples of those as well. And then subclasses cannot inherit each other. Okay, you cannot inherit, so you form this cycle, this internal or infinite loop, and that's not allowed. And they cannot inherit more than one class. So basically just one class. So you cannot inherit from two superclasses or more, right? It's not allowed. You can, however, you can inherit interfaces, as many as you want, because interfaces are not a type of class that can instantiate objects. So if you have like 3 interfaces, yeah, you can inherit them all, okay, which is fine. But if it's a concrete class, then you can't. Okay. So this, again, there's some rules, and using the UML model, it's very common. And when you build languages, build these kind of models to help you code, it's common in programming as well as database designs and so forth. Okay, this UML diagrams. We talked about, again, back to that sandwich class here. This is what's called the has a relationship, because the sandwich, right, composes of 2 other classes, the bread and the filling. So this is not an inheritance. Again, the diagram here you see is how you would draw and correct, using correct notation, is that diamond shape. Okay, the diamond shape, and you attach to another class. You always form a composition. And then in a inheritance, you would draw just something like that, right? The arrow going up to the parent class. Okay, it doesn't mean this child class is the parent class. It inherits from the parent, so it's always the arrow pointing to the parent. That's how they draw in UML diagrams designs. Again, it's just simple notation here. Just means that the first line here is the name of the class. The second box is usually the attributes. These are like your variable names in the class. Data fields. There are actually more info. You have the plus or the minus or the another symbol there to show you whether that is a private or public field. And then the third box here shows all the methods. Okay, and this is just a very, very brief overview of what those look like. But you have a child class, inherit a parent class. So again, it's a relationship. And here is another one. Like you can see this when you do your diagram. A car is a vehicle. A vehicle is not a car, right? It cannot be a car. It could be, but it can be a motorcycle. It could be a plane, right? So not the other way around. And then let's see, here is there's a keyword called super. Okay, when you want to access any data from the parent class, you can always use the word super there, and that will take you to the parent class and use their methods. Okay, especially useful for when you pass a constructor from the car class. You pass data from your constructor to the parent constructor. So that way you can use the parent's constructor to do certain initialization, or even call a function inside the parent class and not your own, right? So just some keywords here again. The word parent class, base class, super class, they all mean the same thing. And then we have the child class, derived class, and the subclass. Those are your child class. Over here we only see like one line from the car to the vehicle. Okay, there could be other classes in between. So really the vehicle could be the grandparent or the great-great-grandparent class if you want to go that route. But really anything above that car class, and if that vehicle inherits another parent class and that parent class inherits another, then the car, as you can see, owns everything above plus its own, right? Again, back to the concept where the subclass always has is larger than the parent class. So you own everything in the car, and the vehicle, if vehicle inherits another class, you own everything there plus the other one too, and then the chain goes up. So it gets really large. And this is also why when you create the scanner class, right, you always inherit the scanner, and you own everything in that scanner class plus whatever you own in your class. So the same idea. And when you inherit a class, you would use the keyword extends. Okay, so extends the parent class. So the child class extends the parent class. Okay, and you can't say like car extends vehicle extends another car extends whatever, right? You can't do that. You have to extend within the class itself. Okay, so and we'll do some examples here in a bit. So the instance operator here is another function or keyword you can use to check whether an object is an instance of a certain class. Okay, especially when you write new code and especially a large application, we instantiate an object of car in somewhere in the program. Maybe you don't know what car is, so it could be like, for example, if you write a program and someone already instantiated an object we call car, and you don't have access to the car class, you don't know what that is, right? And you don't know its ancestors' classes. So you want to check whether the class or the object called car belongs to a certain class above it, a parent class. You can use this to check. It will give you a true or false, whether it's an instance of or member of the class or not. Okay, so this is very useful for that. So here's the multiple inheritance. Okay, one child can inherit one class only, one parent class, but a parent class can be inherited by many child classes, right? So I mean, that's pretty straightforward. If you can also associate that with in the real world. Like if you're a parent, then you can have a lot of children and so on. Okay, so that's that. Here again, back to the vehicle. You have a car, boat, plane, and they all inherit the vehicle class. Then overriding is a part of polymorphism, right? So polymorphism has a couple of concepts inside itself, but mainly these two: the override and overloading. Okay, so they both make up what's called the polymorphism. I mean, you can change forms and active functions. So override deals with inheritance. So I have the parent class here, then I have a child class. That means the child class can override one of the or all of the parent's methods if it chooses to. You can do that. So in this case, I could choose, in this example, it chooses to override the methods for that should be 3. What's method 1, 2, 3? Yeah, it overrides. It didn't show here, but it can override method 1, 2, and 3 because the gray ones are belonging to the parents, and then the dark one down here are the child class methods and attributes, right? So you can override the parents if you want to. If you don't, then the parents' methods are available for you to use right away. Okay. So overriding is when you have a function or a method in the parent class and in the child class, and the rule is that they must have the same name and same signature, right? You cannot change their name and their signature. Whereas the overload is different. Overload, you have the same name, we have different signatures, right? They must have different signatures, and they have to be in the same class. So otherwise, it doesn't work. And that's the difference between the two here. Okay, we'll see that in a minute here. Just some examples. When you override a parent method, usually you put the annotation right above it, like this. It's not required, but it's always good to put that so you know that belongs to, that function is coming from the parent. Okay? If you don't put it there at the end, it's not going to be incorrect. If you put it, it will gray out. It just give you a hint. It's also very good for debugging purposes. If you have a really large application, you want to debug it, you want to find out which one of these functions is a override method, and you put that in there, and it will catch the error for you. It has a method to actually capture that override functions. Okay. The default constructors is just to say that when you, and again we'll do some demo to actually show you how this works. It's just if you have two classes, the child and the parent class, like in this example, the car and the vehicle class, right? The vehicle has a constructor called its own vehicle, and the child class has its own constructor called car. Okay. When you call an object called car, say car 1, then usually it will actually call the parent's constructor first, and then call its own local constructor in the child class. That's the order. It will go all the way from the top of the parent of the chain, and it goes in reverse direction. Okay, that's just the order. So you can, initialize some data in the parent class up here in the constructor, and before it actually, execute the child class constructor. Okay, and so the parent constructor must execute first. It's always execute first, whether you use it or not. So okay. Examples here. Super in this. Okay, so again, the word super in this kind of similar in a sense, except that this uses within the same class. Okay, the word super is calling the parents class. Okay, so if you put like super dot something, it's going to call the parents class method or constructor. This always refer to the current class. Let's see if there's anything here. Okay. Then the access modifiers. There's one access modifier that we have not talked about yet. It's called the protected. So we use private, public, and then there's this protected. Okay, so this protected is usually used when you have this inheritance. So that means that only the child class can access any protected fields or functions in the parent class. Okay, so other classes cannot. Okay, and also they must be inside the same package. If you have another package, and even though your class can inherit from another package, if it's protected, you still can't access it. Okay, it must be in the same package. And again, we'll do a demo to show how that works. Okay, what else is in here? Again, just going over that overriding and overloading. Here again, show the differences. Again, we'll do some examples. Okay, I think this is just some tests down here.